Welcome back, everyone. I'm absolutely thrilled to guide you through another explainer today, where we take complex, invisible systems and break them down into crystal clear, structured layers. We're going on a really fascinating journey to demystify database architectures. We're going to use a super logical approach to see exactly how data flows from a storage drive all the way to your screen, scaling from just a single laptop setup up to massive global networks. By focusing heavily on the key structural differences and some real-world practical applications, we'll map out exactly how our digital world is organized. So let's dive right in. Okay, think about this for a second. When you pull out your phone, open up a highly distributed app like Facebook, and type in a friend's name, where is that profile picture actually coming from? I mean, is it sitting natively right there on your device? Well, of course not. You're acting as a client, tapping into a massive, invisible structural web. Your simple search query is triggering this incredible cascade of digital conversations that all happen in just milliseconds. Right. The images, the videos, the posts, they aren't just magically floating around in the air. They are physically stored on a database server somewhere else in the world. When you search, the application requests that specific data from the server, routes it back through miles and miles of fiber optic cables, and sends it directly to your machine. But the real magic is how those systems are actually connected. Like, how many architectural layers does that single request have to pass through to bring that photo to your screen securely and quickly? So here's our roadmap for this explainer. We'll hit the core concepts, move to a localized one-tier setup, split the workload in two-tier, expand to the three-tier web standard, push the limits with N-tier, and wrap up by looking at how to choose the right one for specific applications. All right, let's kick things off with Section 1, the core of database systems, laying the groundwork. So in this context, database architecture is the conceptual structure and logical organization of a computer-based system. Basically, it describes the precise connectivity between the database itself, the application program used to access that data, and you, the user, who's manipulating it. How these elements are logically separated, or grouped together, dictates the entire tier system we're about to explore. And honestly, that connectivity determines everything from how fast an app runs to how secure your personal data is from hackers. It's absolutely crucial. Moving on to Section 2, one-tier architecture, the local setup. In a one-tier setup, absolutely everything is self-contained. The client computers and the file server, the database itself, are wrapped up in the exact same environment. The user interface, the middleware, and the back-end data all live directly on the client machine. There is zero network separation here. Think of it like a chef growing all their own vegetables directly inside the kitchen. Everything needed to prepare the meal is entirely within arm's reach, so there are absolutely no delivery trucks required. Because of this structural setup, the practical application is highly specific. You definitely aren't running global web apps on a one-tier system. Instead, this is the simplest and most direct method, mostly used by database designers and programmers. If you install a relational database, like MySQL, directly onto your personal laptop to develop and manipulate data locally, you are working within a one-tier architecture. It's perfectly self-contained. That means developers get literally zero latency and they can test their code safely without worrying about breaking a live global server. Let's step it up to Section 3, two-tier architecture, splitting the workload. Now we've got a clear physical separation. In a two-tier architecture, the application program runs on the client side, while the database is stored entirely separately on a database server. To bridge this gap, they use a translation layer called ODBC, or Open Database Connectivity. This crucial little interface acts like a universal translator. It allows the user's application to reach out over a network and talk directly to the database, without needing to understand the database's native, complex language. This structural split unlocks entirely new practical applications, usually within enterprise environments. In a two-tier setup, users interact with the data using a graphical user interface, or GUI, built on client applications like Visual Basic, Visual C++, or Microsoft Access. These client apps then use that ODBC translation layer we just talked about to query heavy-duty database servers like Oracle, Sybase, or Microsoft SQL Server. It's a direct, two-way conversation. You can kind of imagine the client app as a receptionist who talks directly to the warehouse manager, the database, to go pull specific files whenever they're needed. Which brings us to Section 4, three-tier architecture, introducing the middleman. Unlike the two-tier system where the client application and the database talk directly to one another, the three-tier introduces a highly specialized middleman. This is a massive structural leap forward, guys. We are inserting a completely separate application server right in between the user and the data. Why do this? Well, because as applications scale to millions of users, having clients talk directly to your database becomes incredibly insecure and easily overwhelmed. The middleman solves all of that. Think of this architecture like a layer cake with three distinct slices. On one side, you have the UI, or presentation layer. In the middle, the business logic layer, or application tier. And on the other side, the data access layer, which holds the database itself. Even though these three layers work perfectly together to deliver a seamless experience, the brilliant structural advantage here is that each layer can be operated, managed, and updated completely individually. A company can totally redesign the look of their app in the presentation layer without ever having to touch or disrupt the database where all the user information actually lives. The data flow here is just incredibly clean, and it's exactly what makes this the standard powerhouse for distributed web applications. Step 1. The end user operates purely on the presentation tier. Step 2. The application tier processes that request. Step 3. It fetches from the data tier. So the crucial takeaway is this. End users are completely unaware of the database's existence, and conversely, the database has no idea who the end user is. The application server in the middle handles all the mediation. This prevents a rogue client from just downloading your entire database, making it incredibly secure and highly scalable for the global web. Let's zoom out even further with Section 5, N-tier architecture, infinite layers. With N-tier architecture, that N simply stands for any number of tiers. It divides the application into multiple, distinct physical layers, but structurally, it is strictly linear. Every single piece of communication must route precisely through the middle logic tiers. You literally cannot skip a step. Tier 1 talks to Tier 2 to Tier 3, and so on. As web applications become absolutely gargantuan, you might add a fourth or fifth tier dedicated entirely to specific tasks, like maybe a server layer just for processing credit card payments, or a layer exclusively for verifying user passwords before the request even reaches the main application logic. Now, it's really important to contrast this physical structure against popular software design patterns, specifically the MVC, or Model View Controller Framework. N-tier is a physical separation of actual servers connected linearly. MVC, on the other hand, is a logical separation written in code with a triangular interaction. That means the controller can access both the view and the model directly. But here is the really fascinating part. They aren't mutually exclusive. You can actually use the logical MVC code framework inside the physical presentation layer of your massive N-tier setup. It's literally structure nested within structure. How cool is that? And finally, Section 6, choosing the right architecture, matching structure to scale. So to distill the key takeaways from everything we've covered today, choosing your architecture comes down entirely to scale. If your practical application is local development, like testing code with a database like MySQL, you want the one-tier structural setup where everything lives on your machine for zero latency. If you're building internal company software using Visual Basic or MS Access, the two-tier setup gives you that great direct separation between client and server. But if you're building distributed web apps that need to handle thousands of concurrent users securely, you absolutely must upgrade to the three-tier structural setup, adding that crucial application middleware, so the user and the database never actually meet face-to-face. Honestly, understanding this stuff really changes how you look at the software we use every single day. The next time you load up a massive app or just search for a friend on your social feed, take a second and ask yourself, how many invisible architectural layers are linearly routing requests, translating logic, and querying databases right at this very second just to bring that one piece of data to your screen? It's a beautifully complex hidden structure powering our modern digital world. Keep questioning the structure behind the screen, and I will see you all in the next explainer.